Somewhere in a Hubble photograph, there is a single dot of light that should not exist anymore. Astronomers looked at it, ran the numbers, and realized they were staring at a ghost. Stay with me for the next 8 minutes, because this is not just a story about a distant star. It is a story about how far we can actually see and what that distance is quietly costing us. There is a single pixel of light buried inside a Hubble photograph, and astronomers gave it a name. Earendel, one star, 50 to 100 times the mass of our sun, its surface burning at temperatures that would vaporize anything we know. Its light left home 12.9 billion years ago, crossing almost the entire history of the universe, just to land on a mirror orbiting above your head. And here is the uncomfortable part. That star has been dead for nearly that entire journey. Stars this massive do not last. Burn that hot, carry that much mass, and you get a lifespan measured in a few million years, not billions. So Earendel has been gone, extinguished, non-existent for roughly 12.9 billion years. Whatever landed in that single pixel is not a star. It is a photograph of something that stopped existing before Earth finished forming. And it is not the only one. In 2024, astronomers confirmed a galaxy called JADE's GSZ14-0. It's light traveling more than 13 billion years to reach us. Arriving from just 290 million years after the Big Bang, it is too bright, too massive, too structured for something that young.
To understand why that question even makes sense, you have to understand what distance actually means out there, because it is not one simple number. Earendel's light took 12.9 billion years to reach us, but the star itself, right now, sits an estimated 28 billion light-years away. That gap exists because space has been stretching the entire time the light was in transit. Picture someone mailing you a letter and then continuing to walk while it is in the mail. By the time the letter arrives, they are nowhere near where they wrote it, and they have kept moving the entire time you were reading. You can read their words, you will never write back. That is what looking at a distant galaxy actually is, a one-way letter with no return address. And here is a detail almost every explainer skips entirely. We did not find Earendel using raw telescope power. We found it using luck. A massive cluster of galaxies happened to sit precisely between us and that star. Its gravity bent and focused the light like a natural magnifying glass, a phenomenon astronomers call gravitational lensing. Without that alignment, Earendel would be far too faint for any telescope humanity has ever built to detect. And that alignment is not permanent. Galaxy clusters drift, orbits shift over time. The exact geometry that revealed this one star will not exist forever, which means this was never a door we can simply walk back through whenever we choose. It was a window that opened once, briefly, by accident. Now here is where the story turns genuinely strange. As Webb keeps pushing further back in time, it keeps finding galaxies that are too big, too bright, and too structurally mature for how young the universe was. Under the standard model of cosmology, there simply was not enough time for structures like this to assemble. Read the papers describing these discoveries and you will find words like unexpected, surprising, unprecedented, more common than predicted. In casual conversation those words sound like excitement. In a peer-reviewed paper, they are something closer to a warning label. They mean a prediction failed, and nobody currently has a clean explanation for why. To be absolutely clear, this does not mean the Big Bang is wrong. It means our current timeline for how quickly the early universe built stars and galaxies may be incomplete. And there is a second crack running alongside the first one, sitting quietly underneath most of the headlines. It is called the Hubble Tension. Measure the universe's expansion rate using the cosmic microwave background, and you get roughly 67 kilometers per second per megaparsec. Measure the same expansion rate using nearby stars and galaxies, and you get closer to 73. Those two numbers are supposed to match. They do not, and the gap has refused to close for over a decade. James Webb was actually expected to help settle this by remeasuring the cosmic distance ladder at far higher resolution than ever before. Instead, it confirmed that the discrepancy is real. Two different methods, two different, mutually exclusive answers, describing the exact same universe. Nobody involved is hiding anything. Every number in this script comes directly from published, peer-reviewed research. But the honest version of this story is quieter, and considerably colder, than most of the headlines let on. We are watching the earliest chapter of the universe unfold in front of us, and the theoretical framework we use to interpret it appears to be cracking at the same moment we are reading it. Now think carefully about the instrument doing all of this observing. The James Webb Space Telescope sits nearly 1 million miles from Earth, well past the orbit of the Moon. Holding a position at a gravitational balance point no human being has ever physically visited, and with current technology, likely never will. It runs on a finite supply of propellant. Thanks to an unusually efficient launch, it carried extra fuel, pushing current lifetime estimates to around 20 years. But that is still a countdown, not a guarantee. When that fuel eventually runs out, there is no repair mission, no refueling, no second attempt, ever. Compare that to Hubble, which astronauts physically visited and serviced 5 separate times across 19 years. Webb was never designed for anyone to reach it, and its intended successor is not expected to launch until sometime in the 2040s at the earliest. History has not been especially kind to ambitious, long timeline space missions. Budgets shift, priorities change, entire programs get cancelled after billions are already spent. So here is the full picture, laid out as plainly as possible. Right now, humanity can see further back into the past than at any point in our entire history. But the single window making that possible is temporary, extraordinarily expensive, and completely irreplaceable if anything goes wrong. And what we are seeing through that window does not fully match what our best theoretical models predicted we would find. That combination, a closing window paired with a fraying model, is what should genuinely unsettle you. Not aliens, not hidden conspiracies, just the quiet, uncomfortable possibility that we are watching something extraordinary happen exactly